Hello, everyone. It is Saturday, so it's Chat with Mac. We're glad to have you on this beautiful Saturday afternoon. Thank you for joining us. For those of you that have been looking at our videos, we appreciate you. Continue to share, let people know what we're talking about. We're talking about some great stuff, and our YouTube subscribership is growing. Continue to share it. Tell them to hit that subscribe button. For those that are new to what we do, welcome, welcome, welcome. Good afternoon, Nadine.
Good afternoon, Mac. How you doing?
I'm good.
So, I was talking to one of the guys here, and the question came up, and I thought it'll make a good topic. Nvidia had this big event, the big reveal at Computex, and the share prices are going up, and Intel's not doing as good as they want to. I mean, they haven't been doing good for a few years. So the question came is, what is so different? Well, why the change and why now? So just let me give you a little history first. So there are two types of CPUs: the complex instruction set CPUs and the reduced instruction set CPUs, right? So the CISC and the RISC. So the complex ones, they have a few cores, maybe 8, 10, 12, 30, whatever it is. They have a few cores at a fairly high megahertz, so at a fairly high speed. And I say megahertz, they're now measured in gigahertz. So basically what Intel's been doing is it's been making the same type of CPU that has been around since the 8086 chipset, which is the first 86x86 chips CPUs that came out back when the first computers, the first PCs came out. Intel is still making the CPUs that use the same instruction set. Now, in parallel to that, there were reduced instruction set CPUs as well, but they were not the mainstream, like the ARM chips and the PowerPC, the old Macs that were using the PowerPC. Nvidia came up with the idea of making graphic processors because the gaming industry was really taken off, and of course AMD and Nvidia were in a battle, to get that business. What Nvidia did was they found out that for graphic systems, for the graphics cards, chips that have low-powered cores, but a bunch of them perform better. So in other words, instead of having a few cores at a much higher power, you use a bunch of low-power cores, right? And they're actually more efficient. Similar to what the M1 and M2 chips are from Apple, they're the similar architecture. Mm-hmm. So basically, what they found out is that for graphics processing, multiple or a huge set of low power cores work very well. They're much more efficient, and they can get the jobs done faster. So of course, this was when the gaming industry was kind of moving into higher definitions and texturing and shadows and things like that. That something had to calculate all that. I mean, like in a game, if you have something moving and the sun is in a certain way, something has to calculate where the shadow of that object is going to fall. Right. And that's all processing. So Nvidia does great on that. So
they do.
And of course, Intel was still stuck on the same thing. They're still making the same processors. Even now, they're still making the same processors. And the other benefit that Nvidia started to see now is that not only do many low power cores work good for graphics processing, they also work great for AI processing, training transformers for AI. So, and that's what's really the recent uptick in stock price for Nvidia, is that their CPU, their their GPUs, their graphic processing units, similar to CPU, but they're on a graphics card, so they're called GPUs. Their GPUs they handle graphics and AI processing very well. Now, one of the other things that not a lot of people know about, I think we talked about it a little bit, was that many low power cores also work great for mining cryptocurrency.
That's correct. And Nvidia I remember, man, at one point it was hard to even get Nvidia graphics cards at one point because, so many crypto miners were using them for that exact reason. Yeah.
Yeah. So now, I mean, you can't really use GPUs for crypto mining because they've already been mined so much that now you need a special ASIC or basically a specialized processor to get the value back, because the amount of power you're going to be spending you're not going to mine that much currency, so you're not going to get the proper return. But the GPUs that Nvidia makes still do great for AI and AI training, and that's really where the market is right now, and that's really what Nvidia is kind of looking at and focusing on. I mean, they're just all in on this stuff, and maybe people will understand this, or maybe if you have seen in the history of the world. So in the old days we didn't used to have refrigerators, right? So there was a huge industry that sold ice.
Yeah.
That industry was kind of like Intel. That they were selling ice. They were so happy you couldn't make them do anything else because they were like, oh man, we're raking in millions. We're gonna keep doing this. We are good. We're not gonna make any changes. And then this small company came out with a refrigerator idea. But man, these ice making companies, they were still happily making ice.
Yeah.
And what happened? They did not pay attention to where the world was going. They kept doing what they were doing. And then now there's a refrigerator in every house, actually multiple refrigerators in every house, right? Nobody wants to buy ice anymore. I mean, you still do if you're going camping or something, but so the thing is, Intel is in that situation now. And they have invested so much in this CISC chips, the CISC, the complex instruction set chips. They've been around for a long time, since 8086 chips. And they cannot even fathom changing. Basically, it'll be like making a U-turn going back the road they came, because, back when some of the companies were making the RISC chips, Intel was gung-ho. It was like, no, this is the way. And they kept going down that way. And now they're too far down that way. Now we are seeing more and more companies picking up the low power many core concept. The M1, M2 chips from Apple, that's a, similar thing. Now that's interesting as well, because, and I have to think about this, right? Did Apple foresee Intel's downfall and they had to come up with their own chips and their own chipset and their own third-party manufacturing?
They probably did. I mean, we know Apple's been, and this is from somebody that's not an Apple apologist, so let me start with that. But, they have had greater foresight, they were forward thinking as far as some of these things. I wouldn't doubt it if they looked and said, this is going a different way.
Yeah. I mean, it's like, like when the first iPhone first came out, I mean, the technology was there. Anybody could have made it. Nobody had the foresight to do it, right?
Right.
They saw an opportunity, they made a device and changed the world. And and I think that's what's happening here, is that the concept of low power but many cores and that's been proven to be efficient. It's just plain efficient. Because if you have a bunch, like instead of 4, 5, 8, 10, whatever cores, if you have, 150 cores, now you can use as many of those cores as your workload increases and then reduce as many as it's just more flexible.
Makes
And
sense.
since
Yeah.
they're low power cores, you're not using power to power all these cores, right? With Intel, if you have 4 cores and they're very powerful 4 cores, even one core is going to take more power than maybe 30, 40 of the low power cores.
Yeah.
That's where the efficiency, and when we measure compute, we measure it a couple of different ways. And one way is how much power do you have to use to get a certain amount of output, right? And the more efficient a chip is, in essence, it's more powerful. If it's more efficient, you have to put less power in to get the same amount of work back. That means it's more powerful chip, right?
Yeah.
That's what the M1 and M2 chips are. For a lot less power, they're doing a lot more work compared with the Intel chips or even the AMD chips. Now there are some specialized chips like the AMD Threadrippers, and some of the Intel CPUs, they have this as well, where they have a lot of cores, like maybe 40, 50, 60 cores, but still not in hundreds of cores.
Mm.
So that's what's happening is, and I think we are now at this inflection point where AI is kind of transforming the processor industry, the CPU industry, and the effect of that is Nvidia going way up, the low power multi core chips just gaining more and more, compared with the traditional CPU manufacturers.
So let me ask you this, because it seems as if as we go down, as we innovation has become the thing, and laptops are getting a little bit more. I guess you could say getting more powerful as opposed to back in the day. So with Nvidia going down this path, do you maybe see Intel possibly not lasting as long, or maybe Nvidia swallows them up, or is it gotten to the point for Intel where they've been so invested in their current chipset to where they're just like, what do we do now?
So I see where you're going with this, and companies like Intel are like huge ocean liners.
Mm.
In multiple ways. They cannot change course very quickly. They cannot change course easily. And when they're going down a certain path, they're going down that path for a long time. It's not easy to move or change them. Now, eventually, like any other company, and I think Jeff Bezos put it the best way. Eventually, Amazon is going to go out of business. Jeff Bezos said that. Eventually Intel is not going to be there. It's just a matter of time. But that time frame is going to be very long, because there is always going to be a need for an x86 chip for the foreseeable future. Because we have certain things that, for example, they only work on certain chips. I mean, Apple is the only company who has very easily and quickly shifted between RISC and CISC chips. Back in the day when they went from PowerPC to Intel, and then now when they went from Intel to M1 and M2 chips, they are the only company who has been able to execute this really well. Look at Microsoft. Microsoft has tried to use AMD chips in their PCs. They have the Surface Go, flop. They've tried it so many times, flop.
Oh,
doesn't
really?
work. Yeah. So Apple is the only company who has successfully changed the basic architecture, used a different CPU type, and did it successfully. Nobody else has been able to do it, and there's not a lot of competitors who can do it. It's either IBM, Microsoft, Apple. Those are the main ones, right? The industry is going to change, and we are at that inflection point where a whole new not really technology, but a whole new thing like AI really is impacting multiple industries. This graphics chip maker that people outside of the gaming world didn't hadn't heard of before is
It's
all of a
true.
sudden coming up to the forefront. The huge elephant in the room, Intel, is kind of struggling now, having issues. And the forecasts are just not what they used to be, because to run AI, you need to have those many cores to be able to transform or train your AI. So what's been happening? That's why Nvidia is doing so well, and I think for the foreseeable future, Nvidia is going to keep doing well because they have the foresight to invest in AI specific technologies. They are they are coming up with new frameworks and new tools to help developers develop AI, artificial intelligence.
Yeah.
So they're putting their money in the right places. They're doing the right investments. Maybe one day we'll look back at this time and see how the world changed, where we went from huge, when I say huge, comparatively huge processors that were power hungry. They ran hot. They needed fans to cool them down. I mean, some machines even have liquid cooling. They have liquid cooling to
Yeah.
cool the CPU down.
Yeah.
And then Apple comes up with the M1 and M2 chips. They can do the same amount of work even faster and don't even need a fan. And then Nvidia has their GPUs, very low power, but thousands of cores. That does the trick. At the end of the day, it's about conserving power, right? Especially in the mobile world that we're getting into. I mean,
Yeah.
everything is using power. The phones are using
Everything.
power,
Yeah.
laptops, tablets, even cars are using power. So the more efficient we can make things, the better it is.
And so as far as and I'm trying not to segue because AI is always an interesting thing, as far as everything that's been going on within the last couple of months, yeah, the last couple of months with now the browsers and everything using AI. So are we? I mean, you kind of talk about this, and I think you've been really touching on it, but kind of pulling back because you're talking about how Nvidia is investing in AI. Are we going to see a gold rush? I think we're headed towards there, but I'm not sure if it's 100% there. Where now all of these companies, be it IBM, be it whoever, are now pouring tons of money into AI-based projects. Are we just about there yet, or is this
Yeah.
still a little bit of?
So, companies that have already invested in infrastructure that works well for AI are already doing well. I mean, for
So,
example, look at Microsoft, right? Now, Microsoft back in the day figured out, okay, we're going to go all in on the cloud. What is the cloud now? A lot of your AI processing is done in Azure. It's
yep,
not done on AWS. It's
yep,
not done in the IBM cloud. It's not done in the Oracle cloud. It's done on Azure
yeah.
because Microsoft put that money in, and at the same time, they invested in OpenAI. Back in the day, Microsoft was one of the big investors in OpenAI. And that's now they can commercialize those technologies. And a lot of like the back end of ChatGPT actually runs in Azure, right? The transformers and all the processing actually runs in Azure. The big companies have already been investing a lot of money in AI,
Mm, mm,
right? I mean, like the processing, the thing, the change is that we had this moonshot of a leap in technology with ChatGPT, right? When that happened, now all of a sudden it was almost like that aha moment. Okay, aha, this is how we do it. Now we know how to do it. Now we can start doing it. Now we are starting to use it. Like originally we started to do just the chat piece, right? Just getting information. Now you can even have AI draw stuff for you. AI do real-time voice analysis, converse with you, have a conversation with you. So it's just a lot of companies are now putting money into it because we figured out how to train a machine. So instead of giving a machine specific instructions on how to do something, we let it train itself. So in other words, we let it learn. And that's why they're called large learning models or LLM, right? Because they learn on their own. So think of it like you don't have a programmer programming them to do something. They're learning on their own. That was the fundamental change that we made. That was the moonshot, that concept change that we had. And all of a sudden now we're in a place where, it's, I mean, devices have it built in. A lot of devices have that built in. So the thing is, at the end of the day, companies like Nvidia are going to do well for the foreseeable future. They're only going to do better than the companies like Intel, the AMD, those kind of chips. And the reason being because something needs to drive all this AI effort, the training, the transformers, all that. Something has to drive that, and the basic building blocks are going to be Nvidia GPUs, Nvidia chips that make that possible. And we don't see it reaching a plateau. I mean, we just started down this path. We just started. Yeah, we are not even. We haven't even. It's one of those things that we can't even comprehend where it's going to get us to. Right. Wow. It's but amazing times to be alive in.
Amazing times.
So with that, I think we'll call it a day. Just wanted to touch on Intel and the RISC chips and the Intel Nvidia. What's happening there? People have been asking, hey, what's going on with Intel or what's going on with Nvidia? So that's what's happening. The basically the chips that Nvidia makes are very well suited for AI. So that's it. Have a good one, everybody.
You guys have a good one.